The comparison between FPGA and 1080 Ti card, our cell with 9 BCU 1525 FPGA performance on 0x token and skunk hash. This is the main mistake. Before mining on FPGA, you need to consider the following aspects. Hello everyone! Today we're going to talk about FPGA mining, its pros and cons which miners may have, and discuss methods of cooling these cards. For our tests, FPGA cards and bit streams were provided by our partners AET Technologies. While ASIC and GPU mining still remains relevant, high power consumption makes mining a pointless practice in regions where electricity rates exceed 10 cents per kilowatt-hour in the current market situation. That is why miners rediscover FPGA over ASIC and GPU devices today. FPGA excels video cards in terms of performance and energy efficiency and beats ASIC when it comes to flexibility of choosing a mining algorithm. As long as the majority of mineable coins use the proof of work, these cards will allow to mine any coin at any time, which is as relevant as ever in the current market situation. Before mining on FPGA, you need to consider the following aspects. First, each card has limitation of its load capacity by default, but this can be changed via the programming tool for greater performance. Secondly, while changing algorithm on GPU is quite a simple procedure, in the case of FPGA it requires a prepared bit stream, a file that contains the programming information for FPGA, the creation of which is rather a time and money consuming process. The third thing is a high heat transfer coefficient of FPGA in mining and its inability to operate in high performance mode. This primarily concerns stock radiators, which cannot properly cool the card that operates at high capacities. Thus, it is impossible to achieve maximum performance with a standard air cooling. Here we removed the case from the card and now can see a small radiator, which we mentioned earlier. When discussing the subject of FPGA cooling, many people focus their attention on chips cooling, ignoring other components that also heat up when the card is running. This is the main mistake, because chips can heat up and operate even at 110 degrees, while other components of a card will simply melt at such temperatures. For instance, the power regulator. Those scarce as hen's teeth miners who are aware of this problem have a separate cooling fan installed specially for this regulator. The problem with cooling cards can be also solved by water blocks or large radiators for air cooling. However, this leads to additional costs, as in the case of our Xilinx BCU 1525 cards, one water block costs about $200. Besides money, additional manual modifications are also required. You will need to replace the original card radiator with a water block or a huge radiator for air cooling. For cooling in immersion liquid, you don't need to apply such modifications. It should also be noted that all these solutions are focused mainly on cooling chips instead of other components which can overheat faster. Therefore, those approaches are less efficient compared to immersion cooling. Now we are in our lab where the prototype is located, which is our cell with 9 BCU 1525 submerged. When submerging cards into liquid, all their components are evenly cooled. With this cooling method, there is no need to refine the standard cooling system. Liquid easily removes heat from all the spots, reducing the risk of cards overheating during operation in high-performance mode. Now, on the example of two cards, we will demonstrate FPGA performance on 0x token and skunk hash algorithms. On the 0x algorithm, the hash rate is currently equals 15.9 GHz per second. On the skunk hash algorithm, it is about 612 MHz per second. In the miner, you can see the frequency, hash, temperature, voltage, and the amount of solutions. It should be noted that the hash rate is dynamic, it varies in a certain range. The maximum hash rate value we have managed to capture during our test on the 0x token algorithm is 16.5 gigahashes per second, and on the skank algorithm it is 660 megahashes per second. Now we will compare these results with GeForce 1080 Ti card's performance. So, the comparison between FPGA and 1080 Ti card. You can see the consumption and performance in the table. As such, FPGA is 12 times more productive than 1080 Ti, while remaining more energy efficient. Though, at first glance, FPGA is an expensive solution for mining, still it is necessary to take into account that this trend has been actively studied right now, and the developers have been constantly worked on the new bitstreams development, making them more productive and profitable, despite the high costs of the cards. For instance, bitstream for X16R aimed to make FPGA bring a $15 daily profit, according to the developer. We will show you the working rack based on FPGA in the next video. If you enjoyed this one, please hit the like button and subscribe to our channel. If you have any questions, write them in the comments. See you next time!